Okay, so what we discussed yesterday is basically we saw some of the ecosystem component introduction, like Hadoop ecosystem component introduction and the Spark. Okay, we'll focus on today, especially the Hadoop components, and in that I'm going to focus HDFS today. Okay, so we'll start MapReduce tomorrow. Okay, so when we talk about HDFS, sorry, Hadoop. Okay, so we have two main components. Okay, so as I mentioned, one is for storage. Okay, which is going to be a Hadoop distributed file system, which is called HDFS. Okay, and then this is for storing your file in a multiple system in a distributed fashion. Okay, let me use that. I can minimize. Oh, I minimize this. Okay. Okay, so one is HDFS, and then hello, can you hear me? And you are able to see my screen, right?
Yes, Pari.
Okay, thank you for confirmation. Okay, so now, okay, one is HDFS, which is a distributed file system, where we'll keep our files, which will be stored in different computers. Okay, so the terminologies which you are going to you should be familiar is basically I'll be keep using these are the terminologies just to one is mostly we'll talk cluster. Okay, cluster is nothing but a group of computers. Okay, a group of nodes or computers. Computers or servers which is in the same network. It is in the same network. Okay, so then will be so node will called as when you say cluster, it's as we say it is a group of computers or server, right? So each server or system we call it as node. Node is nothing but you can call it a single system, a system or a server. Okay, so these are the few terminologies which will be keep using it. Okay, so if somebody asked what is the cluster size, you can say they means cluster size. You can just say I worked on a 10 node cluster or 20 node cluster or 30 node cluster. Okay, when they ask about specific what is the configuration, cluster configuration, then we'll go detail about each node configuration, right? So when generally talk about the node configuration, right? So particular node configuration, or so we'll just go cluster configuration. When you say cluster configuration, so basically number of nodes, and it's a system configurations. So we'll go in detail about each node's system configuration in high level. Then we'll be specifying the individual node configuration, right? So if we go to individual node configuration, which actually tells the number of cores or the processes cores, number of cores, and then the size of the RAM, the size of RAM and your disk space, size of disk space. Okay, so these are the some of the terminologies. We'll just keep using it for our reference. Okay, so we'll be using these terminologies. Okay, now we'll come back to, we'll go in detail of each terminologies later. And now they'll focus again, come back to the distributed file system and the distributed processing system, distributed processing model or framework. All these are same, which is MapReduce. Okay, so these are the two high-level names, right? HDFS and MapReduce. Okay, now we will go in detail about what is HDFS. Okay, I'll just close this. Okay, now we'll go in detail about. Okay, so okay, before going to HDFS, let's talk about the Hadoop processes or daemons with respect to both HDFS and MapReduce. Hadoop processes as daemons. Okay, so if you see Hadoop cluster, okay, so basically, as I said, Hadoop is basically works in a master-slave architecture. Okay, then you will have one or more master node. One or more master node. Okay, for now I'll just put I'm sorry for this. All control shift. Okay. So I'll call this as M3, which is master node 3, and this is as master node 2. Okay. So you will have master node. So master node, what it does is basically it takes the request from the client. Okay, it can be a file which is like, which can be a request for data storage, storing your data into HDFS, or it can be a file reading, reading your data from the HDFS. All the requests will come to master node. Okay, then the master will delegate. Okay, so you say if you are going to read a file, it will say, okay, your files are converted into blocks, and the blocks are available in respective data nodes. Okay, so this is a master nodes. You will have a slave nodes. The slave nodes are used for storing your data or processing your data. So for two purposes, it will be used. Okay, these are slave nodes. Slave node 1, slave node 2, slave node 3, and slave node 4. Okay, I'll just say yes and 2, and SN3. SN3 and then slave node 4. Okay, so what it is going to do, what is the purpose of using these slave nodes? It is going to do two kind of, it's going to mainly going to use it for storage and computation. For these two purposes, these nodes are going to be used. For master node, so basically handling um, a client request. When we say client, like so basically if the job is the file is getting stored or read from HDFS through master node, mostly the HDFS client will be used. So when you run a HDFS command on CLI, that CLI is going to act as a client. Okay, so that request will come to master node, and it will go and read the respective blocks, and it will give the information. The HDFS client will directly read from this slave nodes. Okay, so handling a client's request with respect to storage or computation. Okay, we'll go one by one. Okay, so we know all right. So these are the like the basic thing. We have master nodes and slave nodes. Okay. Now, when it come to I'll just save this. Okay, now, so now we'll focus on with respect to HDFS. Okay, so HDFS also has a master process and a slave process. Okay, and when it goes to MapReduce also has a master process or daemons and a slave process. Okay, now when we uh, get into the details of with respect to HDFS. Okay, with respect to HDFS, so HDFS has three main process. Okay, sorry for this keyboard is not. Okay, two main process. One is the name node. Okay, this is one process, and another is the secondary name node, and the third one is the data node. So with respect to SDFS, we have three main processes or daemons. One is the name node, and the second one is secondary name node, and third process called data node. Okay, what is name node? Name node is a process which takes care of handling a metadata about your data stored in the slave nodes. As I mentioned, slave nodes will have actual your data. Okay, so master node will not have your data, actual data. It will all your master node will have metadata, the data or the information about your actual data. So that metadata will be on your master node. All your actual data in the data in the slave nodes in the form of blocks, right? Because the HDFS don't store your data on a whole. It will break your data into blocks based on the block size, then it will be stored on your slave machine. Okay, so the data which is storing these slave nodes, right, which will be taking care of, which will be taken care by this data node process. Okay, so again, I'll just give it. This is the master process. Okay, this is the also master process. I will come to know what is the use of secondary name node, but this is also master process. And then you have one more data node, which is a slave process. Okay, now we will take one example. Okay, so your name node will be configured on your master node. Okay, so in the Hadoop 1.x, like in Hadoop 1 version, we add only one master node. Okay, so we can configure only one master node. So that is a single point of failure. If that particular node, so as I mentioned earlier, node is nothing but a server, a single server or a machine, right? So if that node, master node goes down, their entire cluster will not work. Okay, so that is a single point of failure. That is one of the drawback in the Hadoop 1 version. So in the Hadoop 2 version, so they given a feature to configure a master node in master processes in a multiple machines, means more than one machine, so that one will act as a active process. Example, one name node, you generally name node and secondary name node will be configured on your master nodes. Okay, say example, I configured in the this is the master node 1. Here I configuring name node 1. Okay, that will be acting as a active name node, and I may configure two more name node in a master node 2 and 3, which will be acting as a standby. So if suppose some reason, some network failure or something happened in the master node, if it goes down, so so there is a mechanism to just make these standby nodes, so one of the standby node as an active name node, and then the cluster will start working it. There won't be any single point of failure. So that is introduced in the Hadoop version 2. Okay, so that is one information. Now we'll take one simple example. Okay, so we'll consider um, there is a file called sample.txt, okay, which is of size 250, okay, 250 MB. 250 MB. So when we store this, when we want to store this file in HDFS, what will happen? In the MapReduce version, as the Hadoop version 2, the default block size is in Hadoop in V2, the default block size is 128 MB. Okay, so what will happen? This file will be broken into two different two different blocks. Okay, so B1, I'll just use the terminology as B1, which is nothing but block 1. Okay, which is of 128 MB, and B2 block 2 the remaining part. So so 122, right? So B2 will be 122 MB. Okay, so this will be so when we'll store this sample.txt, which is of 256 sorry 250 MB. So it will be when we store in HDFS, it will be broken into two blocks, B1 and B2. B1 size will be 128 and B2 size will be 122. Okay, this is the in theoretical, this is what is going to happen in HDFS. But how this process is going to happen, so I will tell you the flow.
Well, Pari,
Yes.
I have a small question over here.
Sure, sure,
So,
sure. Very well. You can interrupt
so
anytime. Yeah. So
yeah, okay. So, when we are storing 250 MB,
yeah,
so the remaining 4 MB will be wasted, or see, if we are going to use two blocks,
yeah.
so there will be leftover of 16 MB, no 4 MB, I
Six.
guess,
Yes.
or something. Yeah.
6 MB. 6 MB.
So yeah.
Uh,
So how, I mean, in the next process, if you want to use that 6 MB, will master node use that 6 MB as well, or
yes.
that gonna be wasted?
No, it is going to be used because
Oh, okay.
okay, okay. Two point. Okay, one is very good
Mm-hmm.
question. Very good question. This is so basically it is going to reuse that remaining 6 MBs of space. So anyway, when you this file into two blocks, by default it will allocate that 128 MB of size because that is a default block size. Okay, so the next file when you store this 6 MB is free, right? So it is going to use it. Why it is going to use it? When HDFS is you cannot modify a, once you store a file, basically you cannot modify your blocks, right? Is it's kind of write once, okay, write once, read many. That is the concept of HDFS. So you know what I'm saying, right? So basically, when you
Yeah,
store,
yeah.
so when you store a file, that's it. You store it. You may do processing on that file, but you write the result into a different location, right? So the whatever the data you written, just that's it. It's written. You cannot modify it. So the remaining 6 MB of space is going to be used by the other file which you are going to store in HDFS.
Okay.
Okay. So any other questions? So that I'll move.
No, no. We're
Okay.
good.
Sure. So now we'll go to okay. So we know theoretically it is going to split into two blocks and is going to store in this slave nodes, right? So again, I'm just reiterating. This name node will be configured on this master nodes. Example, I'll just put that here will be name node 1 here, and name node 2 will be here. Okay, and name node 3 will be here. Okay. If this is ends, you just reconnect. Okay, the same thing I will connect it back. So the same link. Okay, so it is because of the it's a free version. It disconnect at 40 minutes. Okay. Hello.
Yeah, okay, Pari.
Okay, the same link it will be used. Only thing is it will just disconnect for every 40 minutes. I'll find out the workaround for that. Okay, so your name node is configured on your master node, okay, which is going to take care of your metadata about your data. Similarly, the secondary name node will be configured in one of the this master machine, say maybe in this node or SSM here. And all your data node, I said, is a slave process, though that will be configured in the slave nodes. So this will have data node 1 year, This is going to be a data node 2. And this is going to be data node 3. Data node 4. Okay, that's how it will be configured when they build this cluster, right? So now, okay, so say example, yesterday I told you there are multiple ways you can connect to HDFS. Okay, so means the name node. Okay, so one is basically HDFS CLI, which is a CLI through HDFS command line. Basically CLI means command line. HDFS client, which is CLI. Okay, another way is basically HDFS gives a set of APIs, these client APIs in a so you can use the Java jars. Okay, there are a set of jars is given. Using the jars, you can access the class and you can connect to the HDFS to store or read the files. So one is the Java API. So same HDFS client, but it is in the Java API. And the third is Web HDFS. There is a REST API called Web HDFS. Using that also you can connect. It's basically a REST API. Okay, so people mostly use HDFS client, and if you are actually the system where your data is getting generated, if the system is a Java based system, then people may use Java based API. From that system they will push the data to the HDFS. Okay, and if your system is not a kind of Java based one, it's maybe in different programming language, then you might use the Web HDFS. Okay, so whatever this whether okay, control. We have 6 minutes. Okay, so these are the three ways you can connect to the HDFS. Okay, so I will just disconnect and we'll join again. Okay, so that it will not stop in between. All right.
Yeah, fine.
Okay, thank you. The same link you can connect. I'll just come.